Now let's go to second question for D. Find the x-coordinates of points of inflection. When inflection happens means second derivative of this function equal to 0. So let's go to zoom. I put a 6. That's a standard window. We need to put a derivative for y1 and then the second derivative for y2. How you get the derivative? We go to math. Then move the arrow to derivative 8. Then this will be x. This will be y1. Where you get the y1 is a variable. Y variable. y1. Then over here it will be x. Then go to y3. We still do the derivative of y2, which means the second derivative of y1. So we go to math. Then move the arrow to derivative. Enter. This time still x. Here's y2. So go to variables, y variable, enter. Then this will be y2. Here's x. But I don't want to show the graph of this y1. I only want to show the graph of y3 because I'm looking for inflection. So I will clear this equal sign. Enter. This time, the graph only shows y3. I'm looking for these two zeros. So we do second trace, look at the 2, 0. 1 will be left bound, that's -10. I set up the standard window. Right bound is 0. Enter. Enter. So we got inflection. The other inflection, we still do second trace, 2. Then left bound will be 0. Enter. Right bound is 10. Enter. Then enter. You will get x equals 0.62. In other words, the x-coordinates of inflection points will be x equals 0.63 and x equals -2.1. Now let's go to number 3 for D. Find the intervals on which fx is increasing. Now this time we will highlight this y1 for this equal sign. So the graph only shows y1. We already got the maximum value and the minimum value. Therefore, we can get the increasing interval easily. In other words, for increasing intervals will be the highlighted graph. Since we already got the minimum value over here and a maximum value this point and a minimum value over here, we can write down the interval. Domain of interval will be like this. Let's go to E. The domain of f is now restricted to 0, a. Write down the largest value of a for which f has an inverse. As we know, only one-to-one function has an inverse function. I will make this clear, so change the window into -5. This is a 5. Then graph again, which means from here to this point, it will be the restricted domain. Let's get this minimum value. So we do second trace. 3. Left bound 0, right bound move the arrow across this minimum value. Let's do enter, enter. So basically it will be 1.255. That's the A.
Let's go to E. According to the graphing calculator, we already got the A equals 1.255. So for second question for E, for this interval A, sketch the graph of y equals fx and y equals inverse f of x. According to the graphing calculator, we got this point that will be 0.833 and 0. Then the minimum value, it will be 1.255, negative 1.699. And this point will be 0.5. Therefore, we will set up the coordinate for f of x. You will get 0.5, 0.8330, and 1.255, negative 1.70. For inverse of fx, we switch this xy. You will get 0.833, negative 1.70, 1.255. We will plot these points on this graphing calculator. The green graph, it will be f of x. When you sketch inverse trig function, you have to draw y equals x, because any function and its inverse function will be reflected across the line y equals x. The original function passing through y equals x, that point will be on the graph of inverse function too. So we got all these 4 points, then you connect these 4 points. This will be inverse of fx. The question asks you show clearly the coordinates of endpoints of each curve. Basically, these 4 points. Last question, solve inverse of fx equals 0.5. Basically, we are looking for f of 0.5. So we put into calculator. When you put into calculator, look at the trees, x equals 0.5, you will get y will be 2.44. Therefore, the x equals 2.44.